exponents and exponential functions. So the first thing we're looking at with exponents is what happens when we have zeros as our exponents and what happens when we have negatives as our exponents. So please copy this first part down. This is just a nice example and key for you guys to use when it comes to exponents. So pretty much whenever you have a zero exponent, that means that whatever you are taking to the zero power just turns into 1. It doesn't matter if it's a positive number, if it's a negative number, no matter what, it's going to turn into 1. The only special case here is this last example, because 24 to the 0 power is going to become 1, and then since the negative is outside the exponent, it's going to become negative 1. So one of the trickier concepts with exponents is when you have a negative. So whenever you have a negative exponent, that means that you have to take the reciprocal of your base, which is the number you're taking to your exponent, and the exponent itself. So a to the negative nth power becomes 1 over a. So as you can tell with these examples, 4 to the negative second power, if I want to get rid of the negative, I'm going to flip, take the reciprocal, so that becomes 1 over 4 to the second power, which becomes 1 over 16. Similar process goes with the next one. I have a negative 5. To make that a positive exponent, I'm going to flip that into the denominator. Negative 3 to the 5th power gives me negative 400 or 243. So that is how both zeros and negatives work. Please copy that down. So let's go through just a couple of quick examples. So 2 to the 4th power is the same as saying 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is just going to give me 16. So I won't write all of them out. 2 cubed, 2 times 2 times 2 is 8, 2 squared is 4, 2 to the first is 2. Oop, I don't have equal signs on any of these. Add those quick. Remember, anything to the 0 power is just going to give me 1. And this is where my negative exponents come into play. So 2 to the negative first power is the same as saying 1 over 2 to the positive first power. We know 2 to the first power is 2. So it's the same as saying 1/2. 2 to the negative second, 1 over 2 squared. 2 squared is 4. So that gives me 1/4. 1 over 2 cubed. 2 cubed is 8. So that gives me 1/8. 1 over 2 to the positive 4th power. 2 to the 4th power gives me, 1 over 16. I'm actually going to rewrite this quick. Try that again. And that looks like it was 24. 2 to the 4th power and 16. There we go. All right, so those are just some quick examples of a couple of scenarios. One important thing to remember, a negative exponent does not mean a negative number. This is a super common mistake I see all the way through Algebra 2. It means that the number has to be between 0 and 1, which essentially is just telling you that you're most likely going to have some sort of a fraction. Okay? So, a couple of quick practice questions. So we'll do about half of these and save the other half for class. So if I have 4 to the negative 3rd power, I don't want to work with a negative exponent. So let's take the reciprocal first. So this becomes 1 over 4 to the positive 3rd power. 4 to the positive 3rd power is 4 times 4, which is 16, times 4, which is 64. So this is the same as saying 1 over 64. Okay, we're going to skip the next one. With the third example here, I have 1 over n to the negative third power. So even when you have a negative in the denominator, all you need to do to make that a positive exponent is take the reciprocal. So that just becomes n to the positive third power over 1, which is just n to the third power. All you're doing is taking the reciprocal. Okay, let's skip example number 2. In example number 3 here, I have 4 times c to the negative third power times b. So when you have multiple terms being multiplied like this, I would really just look out for which term has a negative exponent, because that term's the only term that you have to take the reciprocal of. So my 4b, nothing's going to change. Those are positive exponents. But my c to the negative third is going to flip into my denominator to become c to the positive third power. You're only flipping the c in this case. Okay, similar process goes with the last one here, but I'm going to save that one for class. Okay, evaluating exponents looks something like this. So remember, whenever you substitute a number in for a variable, you have to put parentheses around it. This is especially important when it comes to exponents, and you'll see why in a couple of lessons. So I know that n is negative 2. So I'm going to sub negative 2 in for n, taking n to the negative fourth power, so negative 2 to the negative fourth power. W is 5, so I have 5 to the 0 power, and now I just need to evaluate this. So the first thing that I notice here is that my negative 2 has a negative exponent. So let's flip it into the denominator, take the reciprocal. So the reciprocal of negative 2 to the negative fourth is going to make it 1 over negative 2 to the positive fourth power. Oops. Okay, next, let's take care of our 5 to the 0 power. Remember, anything to the 0 power is always just 1, so that just becomes 1. Okay, now all I need to do to simplify, negative 2 to the fourth power, negative 2 times negative 2 times negative 2 times negative 2 is just 16. So I've got 1 over 16 times 1, which is just going to give you 1 to the 16th power. Okay, please, when you start working out these problems, please put parentheses around your substitution, especially when it comes to exponents. Okay, so I know, super quick lesson. Make sure you guys try the examples that I skipped, and that's what we're going to start class with. All right, thanks for watching.